guys, our topic for today is multiplying and dividing scientific notation. We've been working with scientific notation for a few days now, so hopefully you're getting pretty comfortable with it. And as we've talked in class, scientific notation is used in the science world frequently. It's used with astronomers, it's used in space measurement, it's used for little itty bitty tiny microscopic things that can only be measured with numbers like 0.0000064 meters, and who wants to write that over and over and over again? So scientists in the real world don't just use scientific notation to write numbers, they also use scientific notation when they're performing operations like multiplication and division. So today we're going to talk about how you can multiply and divide numbers that are in scientific notation without turning them back into standard notation. And we're doing multiplication and division before addition and subtraction because adding and subtracting scientific notation can get a little tricky. So we're going to go over the multiplying and dividing today, and I think that you're going to find it's really pretty straightforward. Okay? So get this heading, get the objective written down in your notebook, and then let's go ahead and look at some steps to doing it. These notes should be able to fit on the same page of your notebook as your heading and objective did. So first thing we're going to do, very simple, multiply or divide the decimal numbers. That's it. Step number 2, multiply or divide the powers of 10. That's all. It's only 2 steps. It's really simple. You just have to make sure that when you're multiplying and dividing your powers of 10, you're going to use the exponent rules. For example, the rule that we have a to the n times a to the m equals a to the n plus m, where you add the exponents. And then once you're done, you're going to fix any fakers that you have. We talked in the last video about how a faker is a number that kind of looks like it's scientific notation, but actually isn't. Like if we have 16.3 times 10 to the negative 4, this is not actually scientific notation, even though it kind of looks like it, because this first number is not between 1 and 10. We would have to fix the faker by moving that decimal point over one spot to the left, which would then make this number one step higher, so it would be 10 to the negative third. So 1.63 times 10 to the negative third would be how we fix that faker. So let's go ahead and just work through a couple examples. You can do these on the next page of your notebook. At the top, just write example. Our first example is going to be 3.78 times 10 to the third multiplied by 4 times 10 to the negative first. So if we look back at our steps, the first step is multiply or divide the decimal number. So let's do that. We have 3.78 and we have 4, and we're going to be multiplying these numbers together. Now, I use the traditional algorithm for multiplying numbers. You guys might use lattice. That's fine as far as I'm concerned. Just make sure that you get the right answer. So 8 times 4 is 32, carry the 3. 4 times 7 is 28, plus 3 is going to be 31, carry my 3. And 4 times 3 is 12. 12 plus 3 is 15. There were 2 places after the decimal point in my original problem, so there should be 2 after the decimal point in my answer. So 3.78 times 4 is about 15.12. Then the second step of multiplying scientific notation is we're going to multiply or divide the powers of 10. This is where we have to use our exponent rules. So we have 10 to the third times 10 to the negative first. We have the same base here, so that base is going to stay 10. And then we add our exponents. 3 plus negative 1. You've got to know your integer rules. You have to know that that equals 2. You have to, guys. If you don't, see me and I can get you more integer practice. So my answer, what I have, is 15.12 times 10 to the second power. But that's a faker. It is a faker because this first number here, 15, is not between 1 and 10. So we have to get rid of that faker by moving my decimal point, in this case, to the left one spot to get that to a number between 1 and 10. So now that is 1.512 times 10, and when we move that decimal point, we have to change this power of 10 or else it's just not going to be the same number. We moved it to the left, so this number goes up 1, and it's 10 to the third. So my final answer is 1.512 times 10 to the third power. Hopefully you wrote all those steps down in your notebook. If you didn't, you should have. So we're going to move on to our next problem, another example of multiplication. And I want you to go ahead and try this one first on your own in your notebooks. See if you can solve it. Pause the video, and then I'll show you the correct answer. So you need to pause the video within the next 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So first I did 1.1 times 6. That's the decimal numbers in my problem, and I got the answer of 6.6. Then I multiplied my powers of 10, 10 to the third times 10 to the negative 6, which is 10 to the 3 plus negative 6. If I do that math problem using my rules of integers, I get 10 to the negative third. So my final answer to this problem is 6.6 times 10 to the negative third. And I didn't have to fix any fakers because this first number is already between 1 and 10. We love it when that happens. Okay, let's go ahead and talk about some division problems. With division, you're going to do it really, guys, the exact same way, except now you are going to divide your decimal part and divide your power of 10. So let's talk about this 7.2 divided by 9. You're going to have to use long division. It's going to keep coming up all year long, guys. I know you hate it. So we have 9 divided into 7.2. You know what? I'm going to fix that because that kind of looks like it's negative 7.2. And I don't want to confuse you guys any more than you already are on long division. All right, 7.2 went in the house because it gets there first. So does 9 go into 7? It doesn't. Put a 0. Then I multiply. 0 times 9 is 0. Subtract to get 7. And bring down to get 2. Remember the steps. Divide, multiply, subtract, bring down. Then I do it again. Does 9 go into 72? And it does. It goes in 8 times. 8 times 9 is 72. Subtract those two numbers and I get 0. That is my sign that the problem is done. I need to bring this little decimal point straight up into my answer. So I end up with 0.8 as the decimal part of my answer. I'm going to go ahead and erase this and move that 0.8 over so I have room to divide my exponents. And then we are going to use our rules of exponents to do 10 to the 6th divided by 10 to the 4th. And our division rules are that you subtract the exponents. So it's going to end up being 10 to the 6th minus 4, which is just 10 to the second power. So we have 0.8 times 10 to the second power, but we have a problem because 0.8 is actually a faker. We don't allow any fakers in scientific notation. So we're actually going to have to move this decimal point to the right this time to put it after the 8. So our first number becomes 8, which is between 1 and 10. When we move decimal points to the right, the power of 10 gets smaller. So this is actually going to be 8 times 10 to the first. Okay, so there's our final answer written in scientific notation. And if you were to turn this into standard notation, you would just end up with 80. So 7.2 times 10 to the 6th divided by 9 times 10 to the 4th is 80. Okay, let me check our time. We are at, what, 9.5 minutes? Okay, I think I will go ahead and give you a reflection question now. Why don't you go ahead and try, I'm going to skip that one. Try this problem right here. Okay, it is a division problem. Remember our rules. And write your response to this reflection in Edmodo when you turn your assignment in. And make sure to leave a specific question if you are confused on anything. All right, I look forward to reading your responses. Bye-bye.